Welcome to Owie and Sandy Math Along. I'm Sandy.
And I'm Owie.
Number 1, point O is the center of the circle above, and the radius of the circle is 5. What is the length of X, Y? So if we know the circle has a radius of 5, what does that tell us about a couple lengths of this triangle?
Halfway across.
Halfway across the circle. So what lines up there go halfway across the circle?
Well, right.
Correct. So you can write a 5 and a 5 because we know that. Oh, and you got to write it so people can read it. No, I said you got to make it. There you go. Okay, just make it a little darker. Okay. So the Pythagorean theorem I was just telling you about, you can hold that, says if we have a triangle, we can look at the legs of the triangle, A and B, and a hypotenuse. See, do you know what a hypotenuse is?
What's that?
It goes directly across from the 90-degree angle in a triangle. Okay, so it's the longest side of a triangle.
So pretty much like that?
Exactly. That's the hypotenuse. So a squared plus b squared equals c squared is the formula where A and B are the legs of the triangle. So if we know 2 legs of this triangle, how could we write that equation?
You mean like we're filling them in?
We're going to fill them in. We're going to substitute. Yeah, because we have those 5s. How do we write that?
Well, first I think we have to do, just so we remember,
Squared.
5 and then another 5 squared, right?
Right. Okay, is B. You're right. Okay.
So
what is 5 squared?
So 5 squared is 5 times 5.
Okay.
And that equals 25. So that means we have 2 25s.
Equals C squared.
C squared.
Okay, so now C squared equals 50.
So 50.
Yeah.
Oh, 50.
So then you have to figure out what squared equals 50.
So that's just 50. But 50 is not
a perfect square. What is the nearest perfect square to 50?
It's just one below.
Just one below. So then I think we could probably guesstimate that this would be what?
Around 7.
Around 7. You're right. Probably like 7.1 or something like that.
Like, let me just do like
so we'll just do a
7.
Okay.
Like, because of like the arrows like around 7.
So when we found C, that is this length here.
Yay!
Which is exactly what they were asking us for. The bigger the angle, the bigger the leg that's opposite of that angle. So your biggest angle opens to your biggest side. Your smallest angle opens to your smallest side, and middle.
Wait, why do you do...
This is how the problems do is they tell us X is 35 and Y is 55. Okay? So that means this little corner is a 35 and this little corner...
Can I do some calculations?
Not yet. Is a 55. Tell me what angle is the biggest. Okay? And when you tell me what angle is the biggest, you're going to follow it across and then tell me what that line is called. Okay? So for example, if you follow B across, it's AC. Now, I'm going to let you cook with that. Give me the order of these things. How much is this angle?
90.
Okay, so that's 90.
Wait, can I do some calculations?
Sure.
That's 90. It should equal... Wait, I actually know. I can do that math. I only need...
It will equal 180, if that's what you're wondering.
Okay, yeah.
You're really thinking that my math is that bad that I didn't take that into consideration? All right. Which number up here is the biggest? Which angle?
It's the 90.
The 91's the biggest, right?
Yeah, exactly.
And if we follow that across, it matches up to this line over here.
Yep.
Okay.
Wait a minute. So are you saying these lines match up with these lines and these lines?
Yeah, the one that goes across from it. You got it. That's the largest. Okay?
Yeah, so these two lines match up with pretty much the entire triangle.
So what's the second biggest angle?
The second biggest angle is the Y/C.
Okay. And then you're correct. The y degrees, or C, angle C. And then which line does that match up with? You're going to go across the triangle.
Across the triangle, that agrees with A and B.
A, B, you're right. Okay. So next, our medium angle then is AB. And what is the measurement of AB?
Oh, that's 10.
Just 10. Okay. So what I'm going to do is I'm going to write 10 and then put AB like under it and say medium.
Why?
Because that's like our middle biggest. And what's our smallest line then?
That. Then if AC is the largest and AB is the medium, then it's going to be B and C. That's the smallest.
Correct. The smallest is BC. So that's the order we're going in. And then when you draw in your greater than sign, which way does it go between the largest and medium?
It goes like, ah.
You're right. Remember, the alligator eats the bigger number? That's how I always learned it. But I was in Illinois. I never even saw an alligator before, but they said the alligator eats the bigger number.
You never even saw an alligator or a crocodile?
No.
What?
Wild, right? All right.
What? So I see them all the time. Like, pretty much our backyard is the alligator view.
That's so true. So I just realized that I messed up our answer choices when I moved that 10.
Wait, but then what do we do now?
We'll just change these. Hang on.
Greater than 10.
Well, okay, these are our choices. So we're going to ask ourselves, is BC greater than 10?
No.
No. Is AC greater than 10?
Yes.
Yep, AC is greater than 10. So that's one possibility. And is BC greater than AC?
No.
Not at all. So on our example, even though I messed up the answer choices the first time, we only have one option that's true. AC is greater than 10. But this is the process you guys should be using. Start by labeling your angles and then writing in order the lines that correspond from biggest to smallest. Number 3. A farmer creates a pen for his sheep. In mine, it is 7 feet long by 4 feet wide. And the question is, how long is a diagonal that runs through the center of his pen? So if we draw that diagonal in, we suddenly have two 90-degree angles. And I see that I have two right triangles. So we have 7 and 4. That makes this also 4, this also 7. I'm going to look at one of those triangles and figure out what the diagonal length would be. Okay, the diagonal is across from our hypotenuse, meaning it is a C value, okay, the hypotenuse. And we're going to use A squared plus B squared equals C squared. A squared is 4 squared plus B squared. We're going to use our 7 equals C squared. 4 times 4 is 16. Plus 7 squared is 49 equals C squared. When we add these up, we get, let's see, 65. And to figure out what C is, we need to take the square root of both sides, because we don't want C squared, we want just C. And the square root and square cancel out. So I have the square root of 65 equals C. 65 is not a perfect square. You can put that into a calculator, and this would come out to about 8. It would be 8 and a little bit. Okay, so point something. I'm going to guesstimate it at 8. Number 4, in the figure above, ABCD is a rectangle, and CD is congruent or equal to ED. So they want to know what is E degrees, and this is your E. This is the exact same problem that you have on your work. But what I need you to do is actually show me your process. I'm going to give you a hint and then let you go from there. Okay, but I want to try to see your thinking. Oh, he's bouncing a ball in the other room. So CD, this one, is congruent to ED. Wow. And because, there we go, this is a rectangle, we know this is 90 degrees. Okay, so look at that triangle. Owen! I'm not done with the problem, Owen. Owen! Where were we? All right, so if you notice, this triangle has a 90-degree angle and two equal sides. What kind of triangle has equal sides and a 90-degree angle in it? Okay, a right triangle, yes. But remember in class, we did one where it was two different things. So yes, it's a right triangle, but what other triangle is it? Okay, look at those two equal sides. Keep in mind, every triangle ever has 180 degrees on the inside. We already know this one's 90. Okay, so 90 degrees is taken up here. Sides are equal. What does that tell you about these corners, these vertex? And how do they share the rest of that 180 degrees? That's your hint. There's no way for me to do this problem using different numbers. You're on your own. Number 5. On number 5 on my problem, Owie and Sandy start at home. Owie walks 6 kilometers west and 2 kilometers south. Sandy, that's me and I'm Miss Miller to you, walks 3 kilometers east and 4 kilometers north. How far apart are they now? It's a typo even though I, wrote it. Okay, so how far apart are they now? You do have the option, if you want, of drawing a coordinate plane, okay, or using a coordinate grid like on the back of the whiteboards and doing this problem on that plane, okay? I'm just going to use tick marks on mine, but either way works, okay? So Owie and Sandy start out at home, and my marker doesn't work. Boo. There's our home. There's our little home. There's our garage. Okay. It is comfy. Owie said it's so comfy. Okay. Owie walks 6 kilometers west. Well, let's do our compass. North, south, west, east. Never eat soggy waffles. I don't know if they can hear you. Come here, do it. So
never eat soggy waffles. Whoa! Never eat soggy waffles. Whoa! Never eat soggy waffles. Whoa! Never eat soggy waffles.
Thank you, Owen. My students shall never forget the directions of a compass again. He's still singing it. He's actually really cute when he does it too. He looks like a little Muppet. All right. So we walk 6 kilometers west. So we're starting at home and go 1, 2, 3, 4, 5, 6 in the west direction. 2 kilometers south. So 1, 2 in the south direction. And I'll draw a little Owie with his little fade. and his blue eyes and his big smile and his gigantic feet. He's gonna kill me. All right. And then Sandy walks 3 kilometers east and 4 north. 1, 2. I made him too big. 1, 2, 3, 4. And then I'll draw me, Miss Miller, with normal feet. And usually a bun up on the top of my head. That's how Owen always draws me, with that bun on my head. And then I'm like half smiling because I'm happy I'm doing math, but sad that other people aren't happy doing math. Okay. And now we want to know, how far apart are we? So we want this distance right here. This is really similar to the problem you did in the AppleRouth triangles. And it's a very similar picture I did when I shot that video for you. So note, the position of the house is not that important. That's a origin if you were looking at a coordinate grid. Okay? That's like having our origin. So if you are doing it on the coordinate plane, but the distance between each other doesn't include the house. So the way for me to find this distance, the way I want to do it, is I'm going to take hopefully a different color marker, and I hope you can see it because it's thinner. And I am going to draw out a triangle like this. Okay, now you can also do it down here, whichever direction you prefer. I'm going to color it because I really want you guys to be able to see it. And I feel like as I do that, it actually makes it less easy to see. So hopefully that's showing up okay. And now I'm going to measure the dimensions of that triangle. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9 going across. 9 kilometers. Man, we walked a lot. Owen shouldn't go that far by himself. He's just a baby. I didn't call him a baby. Okay. And then up and down, we have 1, 2, 3, 4, 5, 6 total. So my triangle is 9 by 6. And I want this distance right here. Okay. Note the way I drew this, I have a 90-degree angle. Across from that, we point to our hypotenuse. The hypotenuse is the distance we want to get. So a squared plus b squared equals c squared is 36 plus 81 equals c squared. Adding these together, we get 117 equals c squared. Now, to get that c by itself, I want to take the square root of both sides. Okay, because it's being squared, the square root cancels that out. Okay, so it does the opposite. Just like if we had multiplication, we would divide. If we had addition, we would subtract. If we have a square, we take the square root. My answer ends up being c equals the square root of 117. So c equals the square root of 117. That's not a perfect square. The closest that would come to that is a 121, which is 11 squared. So I'm going to guess this is about 10, a little bit more. Let me grab the calculator and figure that out for you. Okay, and that's going to be 10.8. Okay, 10.8 kilometers is our answer. That's how far apart we are now. I do want you to take note of the units. I think that your answer might come out to a whole number, so let's hope. But if it doesn't, round to the nearest tenth like I did, and that should work for you. Number 6. 3 lines shown intersect. As shown, what is the value of x? So they give us, on mine, 65 degrees up here, 90 degrees down here, and that's our x. So it's not a traditional triangle like we've been looking at. The value we want is actually outside of the triangle. However, the value that we want makes a straight line with whatever angle this is. Okay, so kind of think back to last week when we were working with angles like that. Okay, vertical angles or parallel lines with transversals. It's similar there in the process. Okay, we've identified that as a straight line. We know 65, and we know these two lines meet up in a 90-degree angle because it gives us that down here. Well, this also makes a straight line, right? So if that's 90, this has to be 90 as well. So my interior triangle, my actual triangle, we know this is 90, that's 65. We need to find this. That's not so bad, right? The whole inside of the triangle has to be 180 degrees. Any triangles like that. We're going to subtract both of these from 180. So you might use a calculator, and that's okay. That's going to be 515, 155. Okay, if you add those up, subtracting 25 degrees. Okay, so it's kind of a small angle. Again, remember these are not to scale. Okay, so even if it looked really big, you have to go by the numbers. You can't go by what it looks like. They will purposefully try to trip you up on that. Okay, so if that's 25 degrees and it makes that straight line with x, we can say x is equal to 180 degrees, the straight line, minus 25. Calculating. And we get x is equal to 155 degrees. Number 7, triangle ABD is equilateral. What is the value of t? So let's look up at our triangle. ABD is equilateral. Our value for t is way over here. So let's figure this one out. Well, ABD is equilateral. What does that mean? Equa is equal, lateral sides. So all sides on A, B, and D are equal. Okay, they're all the same length. Now, when you have an equilateral triangle, it is also equiangular, meaning equal angles. So all three of these angles have to be equal to one another. Together, they have to be 180. So 180 divided by 3, they have to share those degrees equally. Oh, wow, that's not working. Let me get a different one. I get some more markers. Boo. 60, 60, 60. Okay. Now we can figure out what r is equal to. Seems like that could help us out in the long run, right? So 2r is equal to 60. If we divide both sides by 2, r is equal to 30. Okay, it's still 60 degrees, but the value of r itself is 30. So looking over this triangle, I'm going to use substitution. 4 times r, 120. That's a big angle. That's a 120-degree angle right there. The other hint we had was in the original problem. They said this was 90 degrees, the whole thing. Well, if the whole thing's 90 and this part's 60, what is this little part here? It's going to have to be 30 because 90 total, 60 plus 30 is 90. And now we have a triangle that we don't know what kind it is. It looks like a scalene to me, probably. But we have two angles. We know the whole thing has to be 180, okay? Triangles are always 180, okay? No matter what type, what exact size, the sizes of the different legs, always 180 degrees on the inside. So to find t, which is our goal, we're going to take 180 and subtract the two angles that we know. So minus 120 minus 30. Don't tell anybody I wrote a subtraction problem like that. You're better off combining them first. So 180 minus 150. Okay, that gives us an answer of 30 degrees. T is equal to 30 degrees. That is our answer. Do you want to know something really cool that would be way shorter? Yes, Miss Silver. Oh, wait, I don't even know my own name. Yes, Miss Miller. We would love to see that. Oh, okay, let me show you. Glad you're enthusiastic. If I don't pretend enthusiasm, sometimes I just don't get it. Unless it's Owen. Okay, so we have A, B, C, D, 90-degree angle, and we know we have 2R, and we know we have T. What's funny here is we don't care about that 4R anymore. Don't care about it. Okay, you're going to see why. They tell us ABD is equilateral. That means it's also equiangular. Well, all equilateral triangles are 60 all the way around. My value for R doesn't even matter. Doesn't matter. This 60 doesn't even matter. Now you can leave them written out, okay? This 60 doesn't even matter. What we have now, I'm going to take this line out because it doesn't matter. I have a big triangle with 60, 90, and we don't know this one. Okay, it's actually a special triangle, which we will go over together. But for the time being, we know there has to be 180 total. We're going to subtract our 90 and our 60. 180 minus 150. Does that look familiar? And we get 30 degrees. Okay, much faster that way, much less room to make an error while you're doing the algebra part. You do have to use that initial hint to know this is equilateral, so you can know that that's 60 degrees in this corner. But at that point, ours don't matter. We have a 60, 90, 30.
Ow! I stubbed my toe on the middle
you
bar.
need a kissy?
But I didn't do
I'm
it
not kissing your nasty toes.
Kiss it.
I'm not.
Do it. No.
That's all you're getting.
Straight.
1, 2, and 3.
Straight.
No, not
straight.
Not even for YouTube.
Straight.
Maybe
not
after your shower.
No.
You said you had dance today. You got all sweaty feet. Okay. So mini lesson here.
Well, I was only dancing with middle schoolers.
Girls, boys,
Girls.
Little Steph. Were you wearing your Steph Curry jersey?
No, and dance.
Did they tell you have pretty eyes?
No.
None of them? Oh, baby, they were thinking it. All right. So
they probably weren't thinking of me.
Mini lesson.